Today the topic of discussion is in singly linked list, number of nodes in a loop of the linked list. So in first video what we have seen, what is there loop in the linked list? That is to detect loop detection. No, this was our first video, that you have to detect that there is a loop or in a linked list or not. And in second video, if loop is there, then starting node of that loop, then starting node of that loop, this was our second video, no, of that loop, starting node of that loop, no, this was our second video. So prior to this video we have made these two videos on loop detection and starting point of that loop. Now our third task is, if there is a loop, then how many nodes are involved in that loop, that number of nodes in a loop of a linked list. That if suppose there is a loop, no, suppose there is a loop, suppose there is a loop, then how many nodes are involved in a loop? So there, how many nodes? 1, 2, and 3 nodes are involved. So this is what we have to do in this coding. Now let's start with this coding. So here you have a linked list which we have already seen, and I request you to kindly watch this video. Kindly watch the video prior to this video, then you will understand the coding of loop. So this particular coding is to detect the loop. Okay, fine. So I'll again run this program again so that you will understand how this coding is working. Fine. Okay. So you have a linked list and there is a loop from 3 to 5. Now, is there is a loop? First of all, is how many nodes are there in a loop can only be answered if there is a loop. If there is no loop, then it's useless question. No, it's not a worthless question to ask. If there is no loop, then why I'm asking this question? So let's start with detection of loop first. So we have created a pointer, slow pointer, that is slow p, and we have created a fast pointer, and we have initialized both with head, and the data type of this pointer is node 1. So again I'm telling you, again and again and again and again I'm telling you, kindly watch my first video of linked list, that is create a linked list. Otherwise I'm going to explain you again. So this is the structure. So structure of a node is what is, a node generally have two part, one data and the address of next node. Fine. So we have created a structure having name node. There is two part, one data which is of integer type, and one address is pointer next, which is the data type of this pointer is what, struct node, because this is keeping the address of next node. This is keeping the address of a node, and this node is of structure type. Fine. Okay, so this is why struct pointer next, and then we have created a variable of this structure, and we have type defined it. Why we have type defined it? Now using type def, I can use node 1 instead of struct node. So node 1 is representing the entire structure. Fine. Okay. So in this linked list also there is a there is a two part. So I've made only one part, data part, but there is a two part. One is node and one is address. So now suppose the address of first node is 100, second is 200, third is 300, this is 400, and this is 500. First job is to detect the loop. So again code, we have initialized slow and fast with head. So let's slow represented by s and fast represented by f, and both are pointing to head node, which is 100. Fine. We have created a variable f which is equal to 0. Now we have a loop. So slow p, what is slow p? 100. What is fast p? 100. Fast is also at 100. Fast next, what is fast next? 200. What is fast next? 200. So this is true, this is true, this is true, condition become true. So we'll move inside, and what we'll do, we'll increment slow pointer by 1, that is slow will have slow next, while fast with 2, fast will have fast next. So slow will have slow next, slow will come here, and fast will have fast next, and next fast will come here. Fine. Okay. So again we'll check, that is slow equal to fast? No, slow is 200 and fast is 300. They are not equal. Condition becomes false. Will not go inside the block of if block. Will again check what? Will again check which condition? While condition. So now slow p. What is slow now? 200. So slow is 200. What is fast? Fast is now 300. Fine. And what is fast next? Fast next is 400. It is 400. Fine. Okay. So this is true other than 0. And gate is there. No, 200 and 300 and 400 is true, because anything other than 0 is true. So condition becomes true. Will come inside. Will increment slow by 1. Slow will come here. Will increment fast by 2. That fast will come here. Fine. Okay. And we'll again check, is slow equal to fast? No. Slow is at 300. Fast it has 500. No, it's not equal. Condition become false. Will not move inside the if block. We'll again go and check while condition. What is slow? 300. What is fast? 500. And what is fast next? 500 next is 300. So this is 300. Again, all the condition are true. Other than 0, all AND gate are other than 0. Condition becomes true. What we'll do? Move slow by one step, slow by one step, fast by two step. So first step is this and second is this, because it will come from this place to this and then this there. So fast will come here. Now we'll see the if block. Is slow equal to fast? Yes. Now slow and fast both are at 400. So both are equal. So both are equal. So condition now becomes what? True. Will initialize f with 1. F was 0. Now we have make it 1 and we'll break. We'll come out of the loop. We'll come out of the loop. Break means come out of while loop. Fine. So is f is equal to 1? Yes. We have just initialized f with 1. So loop detected. Yes, there is a loop. There is a loop. Now condition become true. Yes, yes. There is a loop. Now my job is to find number of node in a loop. So what I have called a function here, node count in loop. This function we are calling. So we are calling this function. So the program will jump to the here. Jump here. Again, let address of this node be 100. This is 200. This is 300. This is 400, and this is 500. Fine. Okay. So what we have made a variable counter. So count, we have initialized count with 0. Fine. Okay, so count is 0. Fine. Okay. Then we have a do while loop. Do, no one is stopping me. I'll go, and I'll I'll increment slow by, slow next one. So if I move back, where slow and fast, when loop detected, where was the position of slow and fast? At 400 node. So let us again make this slow and fast. Currently then slow and fast are here. So I'll move slow by one step. So slow will come here, and I'll move fast by two step. So fast here and then here. Fast will come here. Fine. Okay. So slow here and fast here. So slow came here and fast came here. And we'll increment count. So count become 1. Fine. Okay. We'll again check, is slow not equal to fast? Yes, slow is 500, fast is 300. Condition become true. We'll move again. We'll move again inside. Then we'll increment slow with one step. Slow with one step means slow will come here. It will move one step. Slow will come here. Slow will come here. And fast by two step. Fast from this place to this place. So fast will come this place. Fine. Okay. And we'll count again. So count become 2. Fine. Again we'll check, is slow is not equal to fast? Yes, slow is at 300, fast is at 500. They are not equal. So if they are not equal, condition become true. We'll again go inside do. We'll increment slow by 1. Slow will come here, and we'll increment fast by 2. One this and one this. Now slow and fast at are same position. Fine. Okay. And increment count. So count become 3. We'll again check, is slow not equal to fast? Condition becomes false, because slow and fast both are equal now. Both are equal. Condition becomes false. We'll come out of the loop. So we'll come out and we'll print number of nodes in the loop is count. And what is the value of current count? 3. And you can see there are 3 nodes, 1, 2 and 3. So this is the beauty of the code. So this is actually the beauty of the code, which is telling you that how many, if there is a loop, then how many nodes are involved in that loop. So this was all about the coding.